Dear participants, in this session, we will discuss about different implementation aspects of artificial intelligence in forest management and in segment of forest, by which way we can make use of advanced technologies for data management, visualization, data analytics, by which way different organizations, different government agencies are using AI and IoT. Lots of forest reserves, lots of government agencies are already deploying IoT and AI based applications for data management related to agriculture, related to forest. So, whether it is concerned with wildlife protection, biodiversity protection, or it is related to creating virtual boundary walls. Virtual boundary walls means by which way we can create a virtual scenario rather than physical boundary walls to a specific forest location with IoT, with AI, by which way we can see a specific location, whether some particular animals or creatures are moving beyond a particular area. And if this particular type of incident is happening, then how to control it. So many technology based implementations going on nowadays. We will cover with some case studies also in which particular forests or in which specific national parks government agencies are working on IoT and AI based applications. Some demonstrations I will show you related to scripts if you are doing research in this particular domain, then by which way we can collect real time data from satellite. For example, you are working on geospatial data analysis, and that is related to forest or national parks. In national parks or forests, if there is some incidence of fire, then how to control it. So for social cause, for e-governance also, by which way we can make use of technology. Some particular ground stations, for example, you are doing research in IoT, you are working on AI and its merger with internet of things, and we want to propose some research projects for tiger reserves, for national parks, for forest management. In that case, by which way we can deploy certain webcams, certain fire detection or smoke detection sensors, and how to collect data and then predictive analysis. Even lots of portals available. We will discuss about different portals which give you real time data from satellite. Obviously, as a researcher, as a research scholar, or only if we are working on some research project, so definitely we are not having access to a specific satellite, but lots of portals, different platforms are giving access to their satellite, similar to Google Earth, similar to Google Map. And these satellite based portals provide us real time data, real time images from some national parks or uh, forest areas, so that we can analyze the fire, we can analyze movement of creatures or some specific animals, or even intrusion can also be detected, intrusion by human beings or intrusion by something else. Okay, so this is very first scenario that is related to uh, integration of computer vision, integration of AI, IoT and data analytics for forest fire detection. Along with that, we can work with classification and extinction recognition. First of all, I'm showing you some screenshots. We are discussing about some case studies, some scenarios where it can be implemented, and after that, we will discuss about some real time demonstration with some practical codes, with some practical platforms which we can adopt for dynamic capturing of data from multiple locations from anywhere, whether it is India or some specific longitude, latitude. We can specify a particular location similar to Google Map, and then we can check the environmental status. So not only for forest, you can implement it for agriculture applications also. Okay. For example, you are working on some specific project related to agriculture domain, and some data we want to fetch in real time related to weather, related to environmental conditions, or chemical reactions, chemical parameters in soil. So that can also be identified. So these are some use cases: classification, extinction recognition, which specific animals are facing the issues of extinction or disappearing due to any reason. It may be due to killing or anything else, or it may be related to that specific environment or weather is not fit for those specific uh, creatures. Okay, so dynamic data collection from satellite or with own webcam. So such type of dashboards we can create with multiple programming platforms. With either you can use OpenCV, that is Open Computer Vision, Python based platform. In multiple programming languages we can integrate. So whatever webcam we have deployed at specific locations, so those specific images, those particular images can be analyzed with real time object detection, real time creatures analysis, and then we can check how many expected number of creatures should be there in a particular location, and what about the actual figure, what about the actual number. So we can judge, we can analyze the extinction status, or if there is some movement of some specific creatures from that location to any other location. Okay. Analytics of movement climate change effect. You might have seen that because of global warming, such things are happening. However, in case of national parks or forests, which are under government agencies, those are uh, quite preserved. But you might have seen that near to national parks, near to forests, there are lots of urban colonies. Urbanization is there. Okay, and with urbanization, you might have seen that lots of movement, climate change effect is implemented on animals also. They are moving from one location to other location, and because of not getting fit for that specific weather or environment. And you might have seen that in any forest or national parks, you might there are lots of human movements that we call as a safari. Okay, so with that specific instance also, such things happen. But major part is that for administrators, for government agencies, or for policy makers, basically for policy makers or strategic managers, how to decide that whether these particular human safaris or these particular human movements are allowed or not, or how much urbanization, how much industrialization uh, should be adopted, should be implemented in a particular location. Okay, so as far as some particular case studies we discuss, AI enabled very first Tiger Reserve, that is Pench Tiger Reserve. It is already deployed last year in Maharashtra for forest fire detection. Okay, so with deployment of AI and IoT based devices, different sensors, forest fire can be easily detected with different satellites, with different towers. As soon as these sensors detect some particular smoke beyond a specific threshold, so they send some signals, or they alarm at a particular base station, so that predictive analysis or preventive measures can be taken. So this is very first instance, and uh, lots of other tiger reserves, lots of other national parks, they are also working on this particular scenario. By which way we can protect our wildlife, whether it is living, non-living, whether these are related to creatures or trees or some particular human intrusion or cutting of trees. You might have seen lots of instances come to news that illegal cutting of trees or illegal excavation going on in some specific locations. So, how to identify those illegal excavations or illegal digging or illegal cutting of some particular trees or killing of animals? So, AI enabled deployments, these are already available, and this is the technology that is implemented by Pench Tiger Reserve in Maharashtra. That is virtual wall. That is the major. That is one of the major tasks deployed with IoT sensors, with IoT devices. Walls means no need to put a specific physical wall like a prison. Okay, no need to give a prison like feel to the animals or to the creatures of that specific forest. Okay, so virtual wall can be created, or it is, and it is already implemented in Pench Tiger Reserve. Okay, so one instance, one use case is fire detection, forest fire analysis. Second is virtual wall. Virtual wall means, so as soon as some particular creatures will touch that virtual wall or will come to that specific sensor, you might have seen in different high-end locations, security based locations like airports. So when we move near to a door, that particular door opens automatically. So that is similar to a virtual wall. However, that is a physical gate or physical door. But same type of IoT deployment is implemented in different national parks, so that animals, creatures can move anywhere without any physical boundary or without jumping anything. Otherwise, what will happen? For example, some physical wall is established, physical wall is constructed. In that case, what will happen? Physical wall means bricks, brick based, or some cemented or some specific physical object. So definitely that will be having wear and tear in rains. As far as climatic conditions of national parks and forests are concerned, you might have seen or you might have experienced the type of soil in national parks. Okay, so construction of a physical wall, that is very very difficult because it is a very large area, and after construction of a physical wall, it becomes very difficult to maintain it because climatic conditions are entirely different. Very frequent rains, so many different movement of creatures. Okay, even multiple creatures or animals can destroy that wall also. Okay, you can imagine that if a few elephants strike to that physical wall, so in a few moments that wall can be destroyed by animals. But as far as virtual wall is concerned, it cannot be broken by anybody, whether it is human being or it is animal. And as soon as they will move near to that location, alarming system or that signal processing system will be activated. Okay, so these are some scenarios which are already deployed and under consideration by government agencies, by researchers also. Okay, so as a research scholar, as a researcher, as a project associate on this particular scenario, we can propose similar type of projects like virtual wall with real time data analytics and predictive maintenance. Okay, or preventive measures. Another scenario, if we discuss about another use case, that is in Kerala Forest Division, AI based wildlife monitoring. In same way, as far as Maharashtra is concerned, Pench Tiger Reserve, they have implemented it for forest fire detection and virtual walling, so that dynamic data collection, dynamic signals can be received related to movement of some specific creatures. Now, for wildlife monitoring, in terms of their age factor, their survival factor, these are implemented with AI based technology at Mankulam Forest Division, Kerala. Okay, so you can go through these case studies by which way they are working, and robotic applications are analyzing the data. Okay, as far as working on these research projects are concerned, loads of cloud based platforms available which we can use for dynamic detection of specific location and similar type of projects. For example, we want to work on such type of projects, and we want to propose some effective algorithms to government agencies or to the administrators of national parks. In that case, by which way we can do it? Or if our work is related to data analytics or preventive measures or disaster management, in that case, in which format these type of data sets available? Okay, so we will see. So these are some other use cases: smart forest management, monitoring wildlife, predictive modeling, forecasting of fires, spread of illnesses, some particular disease, some particular illness in creatures. Okay, these we can predict. What about their growth factor? Okay, so tracking changes in forest, so all of these can be detected, these can be analyzed. So detecting deforestation also, so illegal digging, illegal excavations, deforestations. So how many trees were there earlier? So with OpenCV, with real time camera images, with real time satellite images, computer vision tools, we will be able to detect, we will be able to work on such scenarios. Okay, now we will see, if we want to work on these implementations, or we want our students or researchers, research scholars to work on such projects, then which platforms we can propose, we can work out. So few platforms I will show you which we can use for data analytics, for real time data analytics. So for forest stat, foreststat.space, and all of these are freely available. Any of whether you are student or research scholar, so you can see, you can analyze the data in real time. So satellite earth observation and AI for forest fire prevention, these platforms are publicly available for researchers, for academicians, for corporate professionals. Forest stat, so all of these links, I will show you multiple platforms. All of these links I have given in my presentation. At end of this session, I will share this PPT to all of you, so that you will be able to work on these platforms. So you can see that billions of animals killed in wildfires. So that's why Pench Tiger Reserve in Maharashtra implemented IoT AI based platform for forest, for avoidance or detection of forest fire, because billions of animals are killed every year. So you can see that 9.3 million hectares of forest loss yearly. So you can imagine, and all of these things are becoming base of global warming also. So you can imagine, if millions of trees are burnt in a specific location, in a specific national park, or uh, in a particular forest, then what will happen to the nearby city of that forest or national park? wildlife smoke damage. Okay, so you can see that this one. So real time data we can analyze on our dashboard, on mobile or tab based dashboard. Okay, so this one is freely available, and you can see that different options available here. Forest fires, different data sets related to some specific forests we can analyze. Okay, so if you need some particular data set related to forest, so we can take it from this particular platform. So this I have given in this presentation. Okay, another platform, that is EOS. If you need some data, if you need some statistics related to forest fire prevention, related to AI implementations, in that case you can use forest stat. If you want to explore this particular data, some specific land based data, then EOS. Okay, satellite data analysis for decision making. Okay, daily earth insights, real time data available. Okay, land viewer, any specific longitude, latitude we can mark, and that specific location we can evaluate. Okay, so you can see that this one. So if we want to see a specific location, so complete world map is available, similar to Google Earth. So where we want to see, at which location we want to see, so you can see different options available. Draw area, upload area. If you have some specific location, you can upload the area also. So you can see that this one. And these are freely available for researchers. eos.com. Okay, different other type of data analytics you can take. Now if we want to mark some specific location, so you can see that draw a rectangle. So you can see that this complete toolbox is available. So measurement is also available. If we want to measure some specific location, for example some forest fire is there, some specific point we want to highlight, and we want to see a distance between 2 points. So all of these options available, and I'm not using any desktop software. It is a cloud based software. Okay, no need to install anything, no need to download anything. Simply on cloud, on your web browser, even on your mobile phone also you will be able to work. So you can see that draw rectangle, I want to draw a rectangle. So you can see with my mouse, with my touchpad, I am drawing this one. And so this area you can see it is increasing. So around 18, so this one is around 2000 kilometers square. So only this part. Okay, this one. And at right hand side you can see that what is land stat, and what about this particular factor. If we want to analyze this specific data, this specific land, okay, is there any instance of forest fire or not, is there any instance of smoke or not. So you can see that this particular location is highlighted. Out of this complete wide area, we have marked a specific location. So if I want to see distance, so distance measure, so from this to this one, so from this location to this location, so 63 kilometers. For example, at a particular point there is some fire, okay, and at remote location, the decision makers, leaders, or administrators of the national park want to see where is the solution or where is the nearest base station. For example, at this particular point there is some instance of fire, and at this location we are having a base station. We want to see in how much time the solution can be reached, the preventive measures or some particular remedy can be reached. So from this point to this point, how much distance is there? So you can see 56 kilometer. If you want to see nearby location, nearby remedy, nearby base station to a specific point, so this one, so you can see 15 kilometer distance, this one. So dynamically we can work out. If I want to save it in a text file, that can also be done. If you want to export it in same way, any other. So lots of different options available. So you can see satellites, so all of these platforms are satellite based. So you can see sugar, if you are working on some agriculture domain, so smart crop id and field boundaries mapping, okay, validates sugarcane mapping in some specific location, okay. This one is land viewer. This one, crop monitoring. If your area of research, if your area of implementation is related to crops for uh, farmers, if you are working on some forest implementation, then EOSDA land viewer, high resolution imagery. So for crop monitoring also you can use it. So this one, crop monitoring, crop health monitoring, wealth risk, this one, weather risks, disease risk, VRA maps. Okay. So with satellite, simply specify your location, simply specify longitude, latitude, or within that particular point you can work. Okay. So it will ask some options. Okay. Now you can see that this one for crop monitoring. Okay. Check weather monitoring. Okay. Its mobile app is also available. If I want to install it on a mobile phone and crop, and in real time we want to view a specific agriculture land, so you can see plan activity. If we want to invite some agriculture scientists, okay, if we want to take assistance or consultancy from agriculture scientists or subject experts, then we can call them, okay, invite our team, okay. This one, add fields, which fields we want to add. Now you can see this one is map. So for crop monitoring we can use this one. If we want to work on forest management, forest fire, then land viewer. So multiple options available in EOSDA. So you can see that this one, at which point we want to see. So wherever our agriculture land is there, wherever our land exists, we can move to that point. So you can see put a dot, it is giving us the complete all options. Put a dot on the map to start drawing. Okay, so you can see that this one, and if you want to monitor it, drawing fields, this one. So with my mouse, with my touchpad of laptop, I am working. So which is my location? Okay, so without having access to my own satellite, no need to launch my own tower. So you can see that this one. How much area is this? This one is exceeding 300 hectares. So you can see that this one. So this location, this particular field, okay, and this is the agriculture land or whatever location I want to analyze. Okay, disease and pests. So you can see at right hand side all options available: disease and pests, weather analytics. Okay, so we can go for that. Save to my files. We want to save it. Okay, so now you can see we are having a complete dashboard on web browser. This one. So sparse open soil, sparse vegetation. So you can see that if you are already working on crop management or agriculture, you are from agriculture domain, you might be knowing these terms better. What is NDVI? Okay, what is sparse vegetation? NDVI 0.3 sparse vegetation, and you can see that this one moderate vegetation. Okay, cloud shadows. So we can see that this one dense vegetation. It means so it is looking similar to that uh, more number of vegetations, or it is more suitable. This particular area is more suitable for vegetations. Okay, so if you are from agriculture domain, then you might be knowing these terms better. Moderate vegetation, okay, sparse vegetation, cloud shadows. Okay, so NDVI, in which terms we want to analyze. So you can see NDRE, or this one, normalized difference vegetation index. Okay, the way in which plants reflect and absorb solar radiation. So these parameters, so we can analyze a particular agriculture land, a specific agriculture location, in terms of these parameters, whether these are fit for our crops or not. Okay, so you can see that modified soil adjusted vegetation index, and by simply mouse over we can analyze it. Okay, and you can see that date wise, if I want to see this particular area at a particular date, at a specific time stamp at this point, so you can see on 16th June, it means 2 months back. So historical data. So what is benefit of this? So if I am having historical data in sequence, for example 17th May, 27th May, 30th May, 1st June, this is time series data. So with data analysis, with AI based techniques, with statistical data analysis in time series, we can predict the upcoming status of this specific land. Okay, so if I want to see this particular location on 7th Jan, around 8 months ago. So 8 months ago, what was the soil quality? What was vegetation index at this specific longitude, latitude, at this particular point? And whether this vegetation index is changing or not, or whether this vegetation index is changing positively or negatively. Positively means it is improving or it is stable. In negatively means it is degrading. Okay, degradation of soil quality, degradation of that specific index. So you can see that this one. Okay, is this visible and clear to all participants? Kindly confirm. Are you able to view this particular implementation? Is it
Yes,
audible?
sir.
Okay, so you can see that. So which model we want to use? So which particular platform, which specific model we want to use? We want to use a satellite, we want to use soil organic carbon map or elevation map. So this one, elevation map. If we want to use slope map, This one is a slope map. Okay, and you can see that. Or with satellite, directly we are communicating, we are fetching data from satellite. And you can see on mouse over, we can see different locations. If you want to work in same way on mobile, on smart gadgets, because nowadays uh, remote monitoring, many times we need to work out on mobiles. So crop monitoring app is available, it is freely deployed. Okay, so whatever you are doing on a web browser, same thing we can perform on mobile phone. Okay, this one, find field, measure distance. We want to measure the distance, place the first point, and this one is second point. So you can see this one. So we want to see some specific location. So it is a, so this complete toolkit is available, and it's multiple dashboards you will be able to create. So customize reports. So you can see that this one, eos.com, carbon projects, satellites, resources. So these options you will be able to explore either for generic satellite data analysis, land viewer for forest management, as we have seen for forest data analysis. If we want to work for crop monitoring, in that case we can go for EOSDA crop monitoring app, crop monitoring platform. And if we want to go for, so you can see that this one analysis, if I want to go for analysis part, so this one, so real time data analysis. So I am not doing analysis manually, this platform is doing each and everything. So on mouse over, what about accumulated precipitation, this one, in which term, NDVI. Okay, normalized difference vegetation index. And in terms of NDRE, what about daily precipitation, daily temperature. Okay, so multiple options you will be having, high resolution imagery, or land viewer, or crop monitoring. So currently we are working on crop monitoring platform. It is cloud based, and I am not using any paid account, it is free account. So that's why it is showing at bottom right, upgrade account. Okay, it is only free variant I am using. And in free variant also I am able to analyze crop data, we are able to analyze agriculture data. Okay, so you can see that this one, on mouse over, daily report. So what about daily temperature? In same way, forecasting, if I want to go for forecast, what may happen after 10 days, what may happen after 1 month. So you can see that today is 20th August, and I want to predict for, you can see that, September 2. What about precipitation, relative humidity, clouds? Okay, spraying time. What will be the spraying time, tillage time? After 2 days, what will be the data? After 2 days, what will be the prediction? This one. Okay, so these applications you can use in same way. If you want to go for high resolution imagery data analysis, so that you will be able to perform with this one, land viewer. Okay, identify facility, this one. So real time data analytics, real time data fetching, and we will be able to save it. So if I want to export it in Excel sheet, so you can see counter exports. If we want to export in Excel format, in CSV format, this particular data will be exported, and we will be able to use it. Otherwise, if we want to use it for analytics part, for example, for research project, for some particular project uh, task. In that case, we can directly take its screenshots. Okay. No need to use our own resources in terms of sensors. So these are already deployed by different corporate giants for researchers. So EOS you can use, and so many other platforms available I'm showing you. So this is the process. Each and every process I have mentioned in this presentation, by which way you can mark. Okay. Some other resources: drone based wildlife protection, drone based wildlife analysis, so that we can do. Another platform, very powerful platform, that is Global Forest Watch, globalforestwatch.org, for forest fire. Global Forest Watch.org. It is also freely available for researchers. Forest monitoring, it is AI based platform. Okay, these are top level corporate agencies working on forest data analysis, forest data based research reports. So you can see which type of data I want to see: deforestation alerts, or we want to work on country statistics, or status of world forests. Okay. So if we want to see data related to forest fire or similar things, similar incidents, in that case we can use it. So you can see forest watcher, radar for detecting deforestation. These are implemented. So with your classical Google account, Gmail account, you can link. Okay. Tropical tree cover replaces. Okay. So if you want to see some analytic part, for example, view deforestation alerts. I want to view this particular data in real time. So in Global Forest Watch, you will be able to see. Okay. So for different applications, for multiple applications, there are separate platforms. If you want to go for crop monitoring, then EOSDA. If you want to go for high quality, high resolution imagery, in that case, you can use from EOS. Okay. So this one. So from which location? So it is giving us view of Google Map, from which location we want to extract data. At any point we can move, and no need to download any software, no need to install any software. Simply on web browser we will be able to work. Okay, on browser based application. So you can see that this location, Betul, Madhya Pradesh, total area, this one. Analyze, I want to analyze this area. Now you can see that in a single click we will be having a complete details of this area, and in real time this data will be available. So what about the status 5 years ago? What about the status 3 years ago? Okay, this one. Integrated. So Google Satellite, that is integrated. If we want to see it, okay, with Google Satellite imagery we want to analyze this location, or with Landsat, with this Landsat satellite imagery we want to evaluate. Okay, or any other location we can see. So for example, we want to work for this location, Andhra Pradesh. Okay, click analyze. And detailed explanation. So very good articles, research projects can be proposed related to data analytics. What is going on in forests? Which type? How much deforestation is there? What about vegetation index? By which and with these data sets, we can propose some algorithms. We can propose some solutions. Okay, these platforms will give you complete data. After viewing the complete data, we will be able to propose some solutions, that how to reduce or how to decrease deforestation, how to improve that particular vegetation index by some technique. Okay, so you can see that this one, detection dashboard. If you want to see it on a dashboard, we want to create its dashboard in a single click. You can see that I am not using any third party software. We are not using any Python or any particular tool. Within this platform, whatever option I have clicked, whatever city I have taken, its graphs are generated. So you can see that this one, historical data, and this historical data is available. Depending upon this historical data, we can present, or we can predict upcoming data with time series methods. Okay, so in real time it is fetching this particular information, weekly data or fire alerts. This one, not only this one, simply click on any location and you will be able to access complete report. Okay, so actually, government agencies are giving more preference to such type of projects. You might have seen many times there are some research fundings by AICTE, by MIT, by different ministries. Okay, and we apply. So, as all of you are researchers, all of you are academicians, you also might be applying for different research projects. So if we will propose the research projects, such type of research projects related to forests or related to agriculture, in that case there will be more chances of acceptance. Okay, so for example, at some particular location, from whatever location you belongs, you want to see the current status of agriculture, you want to see current status of forest area, and you want to propose some solutions. To propose some solutions, first of all we should be having data. If we are not having data, then how it is possible to propose some solution? First of all, we have to find out the loopholes. Which are different loopholes, which are different challenges related to forest fire, challenges related to extinction of animals, challenges related to weather conditions, or any other parameter. Okay, so simply you can point out any location and analyze. Okay, it will give you real time data along with different types of reports in free. Okay, it is completely free. These are not paid software. I am also using free account. I am not having any paid account of these products. Okay, simply take data, or even you will be able to write very good articles, research papers, data science based research papers, focusing to forest crop management. Okay, for example, this one, this particular location. Okay, deforestation alerts. There were around 14,000 deforestation alerts. So you can see that integrated deforestation alerts. So if you want to use this particular data, so it is only this particular paragraph. I want to get complete data. Okay, if these are the deforestation alerts, then what is the detailed data in form of graphs? I want to check that particular data so that I can find out the loophole. We can find out the root cause. What is root cause of these alerts? Dashboard. I will click on dashboard. And as soon as I will click on dashboard, it will give me complete data. You can see primary forest loss in Maharashtra in real time. It is creating the graphs. So you can see this one, this is the graph. Second graph, tree cover loss in Maharashtra. Okay, whatever city, whatever state, whatever longitude, latitude, whatever area we have pointed out in map, it will give detailed report, and we can find out the root cause or the main victim locations, from which locations such type of incidents are happening. So cumulative fire alerts, so you can see that this one. So fire alerts are increasing, you can see that, and its upcoming prediction is also given. So today is 20th uh, August, and you can see if I want to see on September 29, I want to see on August 25. Okay, what about prediction? Tree cover loss. Okay, historical fire alerts. If I want to download this data, you can see that on click of this, download this data. So this data will be downloaded in this zip format. If I want to download it, so on desktop it is downloaded. For example, for my research paper or for my research project, I want to use this particular data set. So you can see that these data in CSV file, in CSV format, these are downloaded. Okay, so you can see that this one, these data sets, so in different cities, in different locations. So simply you can download it. If you want to share it, so you can see share, embed, or download this data, or show on map. On click of show on map, so I want to see uh, which location on map this particular data is related. So this is the symbol, this one, near to Latur. Okay, so if you want to see some location state wise, so that can also be done. So in Chhattisgarh, and which region I want to see, this one. So globalforestwatch.org. Okay. Otherwise, in your papers or in your articles related to IoT, related to environmental management, environmental resource management, and conservation, you can use these data sets. And as these data sets, as these reports are dynamic reports, these are not static reports. Dynamic reports are free from plagiarism. Okay, so no need to worry that you are taking. So you can take this particular report, and we will be able to present in a particular article or research report, research based data. Okay, so either EOS crop monitoring you can analyze, you can go for. If you want to go for that particular global forest watch, multiple tools available. So some more tools I am showing you now, so that you will be able to explore one more platform that is very popular, that is ArcGIS. ArcGIS, ArcGIS for satellite data analysis. Whether you are working on some forest based application, or you want to work on some application related to crop management, agriculture, agribots, real time data analytics, so you will be able to work on it. ArcGIS. Okay, so we can link this platform to programming languages also. For example, I want to link it with Python or PHP. In dynamic way, we want to fetch some data and we want to predict the upcoming data set. Okay, this one. Or actually, to work with these platforms, we need to take a particular data. For example, I want to take longitude latitude data. I want to take forest data from this location. How many forests are there, how many trees are there in a particular location. Okay. What about the environmental condition, what about the weather condition at a specific location? For that, we use GeoJSON. Okay. To If I want to integrate it with Python language, I will show you one demonstration related to Python. So what I'm doing, first of all, I'm explaining what I'm going to do now. For example, I want to present I want to analyze number of trees, number of forests in a particular location. Okay, without using my own satellite. I don't want to use my own satellite. Okay, so this one, and you can see this is world map. So this one from India, I want to fetch real time coordinates related to forest, related to trees. How many trees there, how much area is there. So you can see with my touchpad, okay, I am rotating this globe. So first of all, I will come to India. This is India, and in India, I want to take some specific forest area. I want to work on some specific area. So I am checking that location which is more green. Okay, so that I can work on some dense forest area. So this one, okay, just randomly I am taking this one. Now I want to take a particular location. I want to fetch specific location. So you can see that draw rectangular polygon. Okay. Or if I want to take this one, draw polygon or rectangular. Okay. I want to find out number of forests in a specific location. Click. So you can see that with my touchpad, I am I want to see this point. Click. Now, as soon as I have selected this area, at right hand side this file is created. This one, you can see that this file is created. This is the file. These are the coordinates. If I change this, okay, for example, I want to change this particular point. Okay, this one, edit. Okay, now delete, save. Okay, some more, any other location we want to see. So at which point in India we want to check it? We want to see it here at this point. So this is polygon. So select, I'm selecting with my touchpad only this one. As soon as I have double clicked at right hand side, you can see these coordinates are available. Now what I will do, I will copy these coordinates in a Python code. I'm opening Google Colab. So if some of you are from programming background, from Python programming background, you might be knowing that for machine learning, for deep learning, we generally we work with Colab or Kaggle kernels or Anaconda. Okay, so whatever coordinates I have copied, what I will do, I will use it in my code. This one, forest JSON, and these coordinates I will paste in a code, in Python code, so that I can analyze the forest area in this location. Okay, in this particular location, in this particular state, I want to analyze this forest area. So this code, and these are the, this one is JSON data. You can see that this is the JSON data. Simply copy this particular data from here, this copy, and in Python we will paste, and then we will execute it. This particular code we will be able to use, and we want to see how many locations are there, or what about the area. So it is, this particular code is executing now. So in Google Colab we are working. So you can see forest A, this is the output. Area in square kilometers, 108 square kilometers and 9 square kilometers. This one. So whatever patch we have taken, this particular patch we have taken, and its code from right hand side we will copy, and we can paste here. This is JSON, GeoJSON data. Okay, simply copy and paste, and after that you will be able to work with it. Okay, if I want to take this particular data in tabular format, so that can also be done. Okay, in same way for any other location. First of all we will delete this one, delete, save. Now related to some other point, some other location we want to see it. So these are free platforms for data analytics. Okay, so this, at right hand side this is available, and this code we will copy, and once it is copied, and after that we will execute it in our script. Okay, and lots of other tools available, not only this one. You will be able to use this one, map shaper. Okay, mapshaper.org. Okay, any point, and another, that is your Google Earth or Open Weather Map. One more platform you can take for real-time data analytics, that is openweathermap.org. If you want to link it with your Python code related to some specific longitude, latitude, related to some specific point you want to see. So which type of data we will be able to take from Open Weather Map? So forecasted data. So you can see that APIs. If I want to use it in my script or program, so current weather and forecast, weather data, climatic forecast. If I want to download this data, okay, road risk data, solar irradiance data. So if we are working on solar irradiance, we are working on global warming, solar panel energy prediction. Okay, historical data, statistical weather data, these are available here. Precipitation maps. Okay, so one very simple demonstration I will show you. So fire weather index maps. Okay, if you are working on forest fire, okay, at in real time we want to find out, we want to identify some specific parameters. So air pollution data in a specific national park or forest or agriculture land or near to that location, how much air pollution is there. Okay, fire weather index, ultraviolet index, geocoding. Okay, so if I want to fetch real time data from this platform, so what we do, we have to create our API keys. API keys are created automatically when you create account, and after that we link it with Python. So in Python, I'm showing you by which way we can fetch real time data from Open Weather Map related to air pollution, related to ultraviolet index or solar irradiance. This one. Okay, so for example, I want to put some real time location. Okay, so this is API key, and which location I want to put. So this is the location. Okay, so I can specify here some specific national park like Jim Corbett National Park, like Pench Tiger Reserve. Okay, or some specific uh, forest location. So we will simply, so this particular API we can use. So this is API, you can see this is API key. From where we will get this API key? As soon as you will create account on Open Weather Map, you will be able to get its API key. Okay. So and once it is executed, then you can see this one. If I want to locate some specific location, okay, Open Weather Map, and we want to identify real-time parameters. Okay, for example, okay, or this one. So Chennai, this one, humidity, weather, cloud, temperature, and other parameters. Okay. So either by scripting, so both options available. If you want to work on GUI based software, then you can work with this one, EOS, real time data monitoring, real time data analytics. Okay, no need to use any programming language. If you want to work with your own script with JSON data, with longitude, latitude, with coordinate data, in that case we work with GeoJSON with Python. So you can see this one. So anywhere, so it is open for everybody, for all researchers, for all academicians. Simply you will have to link your Python Colab, okay, Python Google Colab notebook, and you will be able to work with it. If you want to take real time data related to some specific location, like ultraviolet index or solar irradiance or similar parameters, then Open Weather Map, this is, it is providing free APIs, and those free APIs we can link with our code. Okay, if a larger area, so simply this one, if I want to state, take this one, at right hand side, this it will be copied, and we can paste these parameters. So these are real-time coordinates, and these coordinates we will put in Python code, and then we will be able to work with data analytics. Okay, so these platforms you can explore for your data analytics part, for forest data management. Okay, so I will share this presentation to all of you so that you will be able to work with it. Okay, very soon I will upload this presentation on cloud. Okay, so in this way. So VRA map, if you want to see VRA maps, sowings, vegetation index, whether vegetation is possible or not. So this one, monitoring, field analysis, that you can perform. So each and everything is done online with cloud-based platform, and on mouse over you can take. Okay, if you want to download this data in Excel sheet, you can see download. In Excel sheet format, you will be able to download it, and so contrast view, okay, on different parameters. So as a researcher in data science, AI, forest management, environmental conservation, environmental resources, natural resources management. We should be aware, and we should keep on exploring these platforms so that very effective real-time outputs can be generated. Okay, so you can explore these platforms. Now, dear participants, I am sharing my presentation to all of you, and last few minutes of this session are for your queries. I will share this presentation in cloud link in chat window. Dear participants, link of this presentation is given in chat window. Kindly confirm is it downloadable or not. Simply click on this presentation.